Good morning everyone. In this video I am going to discuss about linear ramp type digital voltmeter. This is an important topic for the students of EEE as well as those preparing for competitive exams. Let's get started. Linear ramp technique. The basic principle of such measurement is based on the measurement of the time taken by a linear ramp to rise from 0 volts to the level of the input voltage or to decrease from the level of the input voltage to 0. This time is measured with the help of electronic time interval counter and the count is displayed in the numeric form. With the help of a digital display, basically it consists of a linear ramp which is positive going or negative going. The range 0f the ramp is plus 12 volts while the base range is plus or minus 10 V. The conversion from a voltage to a time interval. At the start of measurement, a ramp voltage is initiated which is continuously compared with the input voltage. When these two voltages are same, the comparator generates a pulse which opens a gate, i.e., the input comparator generates a start pulse. The ramp continues to decrease and finally reaches to 0 volts or ground potential. This is sensed by the second comparator or ground comparator. At exactly 0 volts, this comparator produces a stop pulse which closes the gate. The number of clock pulses are measured by the counter. Thus the time duration for which the gate is opened is proportional to the input voltage. In the time interval between start and stop pulses, the gate remains open and the oscillator circuit drives the counter. The magnitude of the count indicates the magnitude of the input voltage, which is displayed by the display. Properly attenuated input signal is applied as one input to the input comparator. The ramp generator generates the proper linear ramp signal which is applied to both the comparators. Initially the logic circuit sends a reset signal to the counter and the readout. The comparators are designed in such a way that when both the input signals of comparator are equal then only the comparator changes its state. The input comparator is used to send the start pulse while the ground comparator is used to send the stop pulse. When the input and ramp are applied to the input comparator, and at the point when negative going ramp becomes equal to input voltages the comparator sends start pulse, due to which gate opens. The oscillator drives the counter. The counter starts counting the pulses received from the oscillator. Now the same ramp is applied to the ground comparator and it is decreasing. Thus when ramp becomes 0, both the inputs of ground comparator becomes 0, grounded, i.e., equal, and it sends a stop pulse to the gate due to which gate gets closed. Thus the counter stops receiving the pulses from the local oscillator. A definite number of pulses will be counted by the counter during the start and stop pulses which is measure of the input voltage. This is displayed by the digital readout. The sample rate multivibrator determines the rate at which the measurement cycles are initiated. The oscillation of this multivibrator is usually adjusted by a front panel control named rate, from few cycles per second to as high as 1000 or more cycles per second. The typical value is 5 measuring cycles per second with an accuracy of plus or minus 0.005% of the reading. The sample rate provides an initiating pulse to the ramp generator to start its next ramp voltage. At the same time, a reset pulse is also generated which resets the counter to the 0 state. The advantages of this technique are: 1. The circuit is easy to design. 2. The cost is low. 3. The output pulse can be transferred over long feeder lines without loss of information. 4. The input signal is converted to time, which is easy to digitize. 5. By adding external logic, the polarity of the input also can be displayed. 6. The resolution of the readout is directly proportional to the frequency of the local oscillator. So adjusting the frequency of the local oscillator, better resolution can be obtained. The disadvantages of this technique are: 1. The ramp requires excellent characteristics regarding its linearity. 2. The accuracy depends on slope of the ramp and stability of the local oscillator. 3. Large errors are possible if noise is superimposed on the input signal. 4. The offsets and drifts in the two comparators may cause errors. 5. The speed of measurement is low. 6. The swing of the ramp is plus or minus 12 volts. This limits the base range of measurement to plus or minus 10. Versus if you find this video help, please like, share and subscribe to my channel for more education content. Thank you.